All right, Izzy, I hope you're feeling better. I've kind of lost my voice a little bit, so bear with me. I'll try my best to explain these problems. All right, first one says determine whether it has a maximum or a minimum value. Here's problem number one. Because right here, this is positive, that means A is positive, it's going to open up. That means that the point that we get for the vertex is going to be the minimum. So that we know right away, as soon as we see this is positive, there's going to be a minimum because it's going to open up. And the vertex that we find is going to be the very, very bottom. Now it says state the minimum value. So that means I'm going to find that vertex right there by using negative b over 2a, where this is my a number, this is my b number, this is my c number right here. That's going to be negative 5 over 2 times 1, which is negative 5 halves, or negative 2.5. That's what that is. That is the x value, remember. And then right away you could probably look at those choices on there and see that the only one that says a minimum and has negative 2.5, that's going to be C. So I know this one right away is going to be C. But then you could take that and plug that in to find your y coordinate. So if I take negative 2.5 squared plus 5 times negative 2.5 minus 6, that's going to end up giving me negative 12.25. Then again, for the range, if you're looking at it, if I graph that, that is negative 2.5, negative 12.5, so probably down here somewhere. Opening up, there's your minimum value, the vertex. And sorry if I spelled minimum wrong. That's the vertex right there. That is the point, negative 2.5. The range measured from here up is how it's written. Y is the element of all numbers more than or equal to all the numbers above negative 12.25. That's where they get the range right there. So there's your range. There's your minimum value. Your domain are going to be all real numbers from left to right. And then it's going to have a minimum. All right, problem number one. Problem number two. This says which one corresponds to the graph shown. So I'm looking at that graph on your study guide, and it looks like the way it's drawn, it goes way down here. Looks like a little bit to the right. So it looks like barely a fraction for x, and then way down here by negative 12 for y. So almost like the one above, but 2.5 maybe negative 12.5. So that's what that one looks like approximately. So I need to find which one of these has that. And again, I'm looking at your study guide problems. I'm looking at problem number 2. Of those choices, they're all positive, so I can't rule out one of those because they're negative. They're all opening up. So I need to find the vertex to try to find that to be 2.5, negative 12.5. All right, so if I plug these in, it looks like choice F has x squared plus 7x. So that would be negative b over 2a. And I can see that's negative, but this vertex is positive right here, so this one's not going to work. If I look at choice G, which is x squared minus x, that b term right here would be -1 over 2 times 1. That gives me a half. So that's looking pretty good. I mean, this could be about a half right here. 1.5 maybe, or 0.5, about a half. And then if I plug that in, that gives me 1/4. And again, I could see that is going to give me something around -12. So I'm going to keep G on my radar there, because it looks like that one, using this as B and A, gives me something close to that right here. All my other ones, if I look at choice H, that gives me -5/2. And again, I can't have that because this vertex is positive. If I look at J, and use this -b/2a. Remember, I'm all using -b/2a. That's what I keep doing. So that would be -12/2. And then -6. And I can see that doesn't match that. So out of all these choices, G is the only one that had a positive value for x. That's the only one that's close to this graph. So that's got to be G. All right, number 3. It says find the axis of symmetry and the coordinates of the vertex. Alright, so for this one, I'm going to find the coordinate of the vertex first, and then know that the x coordinate gives me what I need for the equation of symmetry. So here I go. There's my A, there's my B, there's my C. So -b/2a gives me -12 over 2 times 2, which is 12/4, which gives me 3. So I know for the vertex there, the x coordinate is going to be 3. I know because this is positive that it's going to open up. So this is going to be a minimum, my vertex. I know that the equation through the x coordinate gives me the line of symmetry. So it's going to be x equals 3 when we get to that. But now I need to find the y coordinate by plugging this in right here and right here. So here I go. Y when x is 3, and all those x's I'm plugging in 3. That gives me 2 times 9 minus 36 plus 2, which gives me 18 minus 36 plus 2, which I believe is -18 plus 2, which gives me -16. And I do not see that on any of those choices because it looks like I wrote the problem wrong. So here I go. There's a common mistake. This is a 6 right here. So don't make mistakes like that. Gotta be careful. Write down the problem correctly. And that's where they get the -12 right there. So the way this graph looks, over 3, down 12 from my vertex. It's going to open up. This line cutting through that x coordinate is the line of symmetry that cuts this graph in half. If I factored it and solved it, I could find my roots where it's touching the x-axis, remember? But again, this one has a minimum vertex coordinate of 3, -12, a line of symmetry of x equals 3. All right, here we go, number 4. It says find the coordinates of the vertex of the graph y equals -2x² minus 8. Identify is a maximum or a minimum. So here we go. Right away, I see that this is negative, so it's going to open down. I have no B term, and I have C is negative 8. So here I go to find this vertex. Negative B over 2A. Since there is no B term, it's 0 up there. Negative 0, same as 0. Over 2 times negative 2, but whatever that is, it's going to be 0. Because this is opening downwards, this is a maximum. To find the y number, just take that 0, plug it in for x. This gives me 0 minus 8, so that is negative 8. So that is my coordinate of my vertex, which, because it opens down, is a minimum. And that looks like choice J on that one, where number 3 was choice B for number 3. 2 looks like the answer was G, and then 1 so far looks like the answer was C. Alright, here we go. Let's keep going. Number 5. It says, what are the roots of the quadratic equation graphed at the right? So the way that graph looks, you want to find where it's touching the x-axis. Those coordinates for x are the roots. Looks like it's opening right here. Looks like it's going down at 4. Looks like the vertex is 2, 4. It's a maximum. This means A would be negative. This would be like a negative x squared problem. Those are my roots. Positive 4 and 0. And remember the factored form, and that's choice C, by the way. The factored form of this would be x plus 0 and then x minus 4. It would have a negative in it because it's opening downwards. Alright, here we go. So that one is number 5 is choice C. Number 6. How was the graph? And it has g of x equals x squared minus 3 related to f of x equals x squared. Alright, well, it looks like this one's being transformed to get the new g of x. It looks like the transformation I'm doing here is g of x is f of x minus 3. That's what that looks like. So if I take this for f of x and plug it in right there, it's making this go down by 3. So my transformation is translated down 3 units. Which means the way this graph looks, I have x squared right here. That is f of x. The new g of x is this one down here, which is the original x squared graph, but shifted down 3 units to get this down here. That is the vertical shift going down 3 units to get my new g of x. So 6 is choice A. Alright, number 7. 7 says find the value of c. That makes it a perfect trinomial. So you're completing the square here. Which means, remember, you take half of b squared. So you take half of 10 which is 5. That's what you're adding squared to both sides. That value is 25. That's the actual value. If you were to complete the square, remember how I showed you, whenever you add half of b squared, remember it always skips down to this x, this plus, this 5 squared. And remember, that's a shortcut for what's going on in the middle here. Remember, this is 25. That's your c term right there. C is 25. If I were to factor this using the x method, that would be 5 and 5, remember. So this would be x plus 5. And since there's 2 of these, that's why we write this squared. So again, we want you to just skip this middle step and know whenever you add half of b squared, which is your c term, that automatically. All right, that was number 7. All right, number 8. 8 says find the roots using completing the square method. So I'm going to get this 12 on this side right here. I'm going to take half of b. I don't care, it's negative. I'm just going to take half of b, which is 1. I'm taking the absolute value of that. Half of 1 squared is what I'm going to add to both sides. And half of 1, I'm sorry, is 1/2. Half of b. That's what I'm adding squared. Remember, this little trick ends up being x and minus and 1/2 squared. I want you to skip all that middle part here. Always when you add half of b squared, always x minus whatever that is squared you're adding. That goes right here. Got to do the same to this side right here. Ends up being 12 plus 1/4. So we'll call that 12.25. How about that? Maybe make this a decimal problem. I'll eventually change that to 0.5. I'm going to square root both sides. That cancels out that. It gives me x minus 1/2 equals plus minus the square root of 12.25. So I'm going to solve both these. One answer comes from x minus 0.5 equal to the square root of 12.525. Sorry. The other one is x minus 1/2. Don't change that, remember. That never changes. Only the sign on the root number right here. So over here I'm going to add 0.5. So one answer is 0.5 or 1/2 plus the square root of 12.25, I believe. And the other one gives me 0.5 minus the square root of 12.25. Pretty sure on that one. We will have to double check, but again, half of b, which is 1, half of b is 1/2 squared. That's what I'm adding to both sides. Gives me 12 1/4, 12.25. This, always remember the trick. Always ends up being like that. Square root both sides, the inverse operation that. Remember, when you split it, never change the x minus 1/2. That stays the same. Only this is plus, only that's minus. All right, number 9. Has you solve using the quadratic formula. Where A is 2, B is negative 15, C is negative 8. Remember the formula, negative B plus minus the square root of B squared minus 4AC over 2A. Plug them in. So it's going to be negative 15 turns to plus minus the square root of negative 15 squared minus 4 times 2 times negative 8. That's going to be a double negative right there. Turn to plus. Don't forget the over 2A. That gives me positive 15 plus minus the square root, and let me use my calculator. 15 squared is 225. This turns into a plus because you're multiplying two negatives here. Negative 8, and then negative 8 times negative 8 gives me positive 64 all over 4. 225 plus 64 is 289, which I think is perfect root number. The square root of 289 I think is 13. Let me see. Sorry. So this becomes 15, and I'm going to do this on the back. 15 plus minus 17, because that square root symbol goes away, all over 4. That breaks down to my two answers. One answer is 15 plus 17 divided by 4. One answer for x is 15 minus 17 divided by 4. That gives me 32 divided by 4. So one answer or one root is 8. It would touch at 8 on the x-axis. This gives me negative 2/4, which is negative 1/2. I know that this problem right here is opening up because it has got a positive a squared. I know that my roots are right here at negative 1/2 and 8. So it's going to open up something like that. It's going to have a minimum. Alright, so that was problem number 9. Alright, problem 10. The discriminant, which is just part of the quadratic formula, which is this part. Underneath the radical, you're looking at just this part right here. Not even really worried about the radical here. So here's my A, B, C. If I plug those in, the discriminant tells you stuff. Gives me 36 minus 44, which means this is going to give me a negative number underneath my radical, negative 8, which means this has no real roots. It doesn't have answers that touch the x-axis. That means this one is one of these upward opening ones, up because it's positive, that is up here in space. It means it's still a parabola with a vertex, but it doesn't cross the x-axis. There's nothing you can do to factor that. This gives you an imaginary number situation, a negative. Remember, the other ones are this. If you have a positive number underneath there for the discriminant, that means you have two real roots. If you have a negative, no real roots. Positive number underneath the discriminant, two real roots. If you have a 0 under there, that means it touches the x-axis in one place, one real root. So know that discriminant, plugging in those numbers A, B, and C, tell you what your graph is going to look like, whether it's going to touch the x-axis no times, 2 times, or once. And then of course A tells you if it's opening up, and if this is negative it would be opening down. Alright, number 10. Number 11. This one says solve using any method. So it looks like y squared plus 8y. The way it's set up looks like completing the square. So that's what I'm going to do. Add half of this square to both sides. Remember the trick. Y. This sign plus whatever number you're adding squared to both sides right there. Don't put 16 in there. And then over here, you want to get that 16 to add to that 2. Don't forget your square right there. So you get y plus 4 equals 18. I'm going to square root both sides. Gives me y plus 4 equals plus minus root 18. One answer is going to come from y plus 4 equal positive root 18. And the other one's going to be from y plus 4. Don't change that. Equal negative root 18. So I'm going to do 18 on my calculator and square root it, which gives me about 4.2. So for this one, subtract 4 gives me about 0.2. For this one right here, when I change this to negative 4.2, looks like about negative 8.2 right there. It looks like the closest answer to that one would be, looks like F has positive 0.2, negative 0.82. The other ones are close. G is close, but it has positive 8.2 and it's not positive. So it's not G. H and J are a little bit off. This one's going to be F for number 11. All right, number 12. Number of solutions, discriminant test. Here we go. So n squared minus 10n minus 5 equals 0. Remember, discriminant test is just this part. That would be underneath the radical when you're doing the quadratic formula. Positive, 2 real solutions. Negative, no real solutions. 0, 1 solution. So here I go. Plug in A, B, and C. It's going to be negative 10 squared, which is going to end up being positive 100, minus 4 times 1 times negative 5. And I really don't need to do any work. This is going to be positive. This right here, double negative, is going to be positive. So no matter what, I'm going to get a positive discriminant number. 2 real solutions, which means 2 roots, which means if you graphed it, touch the x-axis in 2 places. So that would be B on that one. 13. Look at the pattern. This best describes the data. Looks like this is going up by 3, going up by 3, going up by 3. Any pattern that goes up by the same amount for y is linear, is a straight line. This would have the equation y equals how much it's going up. That's your slope, 3x plus whatever y is when x is 0. That's the equation for this. This one is a linear situation, straight line. Whenever you're adding by the same amount each time, linear. All right, 14, here we go. 14. Zero, 1, 1, 3, 2, 9, 3, 27. This one looks like I'm timesing by 3. Anytime you're timesing by 3, that's going to be one of these exponential graphs that look like this. Exponential. Which means this equation, a little bit more weird, would be y equals, and we'll say the 0 term, we'll say 1 times 3 to the x power. A little bit more weird, but don't worry about that. You'll see more of that in Math 1. Exponential, so that would be g, where 13 linear is f. And then bonus. What are the equation of the axis of symmetry of a parabola? Here we go. So this one has roots, x-intercepts -3 and 5. Remember, the way that would look in factored form would look like this. Not x minus 3, it would be x plus 3. Remember the opposites. When you solve these equal to 0, that gives you what the answer is right there. So if I factor this or FOIL this, it will give me x squared minus 5x plus 3x minus 15 equals 0. X squared minus 2x. So that's the equation right there. If I put that y there, that's the equation for this. So there's my A, my B, and my C. So I could use that to find the x coordinate, which gives me the equation of the axis of symmetry, of course. So negative B over 2A would be negative 2 over 2 times 1, which is 1. So my vertex over here has 1 for x. I'm not sure what y is. I don't really need that to solve this bonus problem. All I need is that 1 number. So I don't know what y is. I can probably find that out real fast. Let's do it. So 1 squared minus 2 times 1 minus 15. Y equals negative 1 minus 15. Sorry about that right there. Plugged in 1 here into the equation. So y looks like negative 16. So back to this problem right here. It looks like my vertex is 1, negative 16 way down here. It's opening up. It's touching the x-axis at my roots, negative 3 and 5. And of course, my line of symmetry cutting right through the vertex is this x equal 1. That's the equation of the line of symmetry with those for its vertex or for its intercepts. Alright, good luck. Hopefully this helps. I'll be happy to be working with you on these. Good luck, good luck.